In this today's class, we will learn a few numericals on combination of resistances from the chapter Electricity, class 10. We'll start with basic things. Let's say here we got a circuit. Let's say the current is flowing from point A to B. Okay. Assume that the resistance of first resistor as 2 ohms. Okay. And take the resistance of second resistor as 3 ohms, and you can assume the resistance of third resistor as 5 ohms. Done. Now here you should observe one thing. The current which is passing across these 3 resistors, whether it is dividing or the same current is passing through all the resistors. Here you can see that the same current is passing across all the 3 resistors, right? That means I is constant. As I remains same across all the resistors, we can say that the resistors are connected in series connection. Series connection. That is, you can say that all these 3 resistors are connected in series connection. So if you take the equivalent resistance of 3 resistors when they are connected in series, it is equals to sum of all the resistances of these resistors, right? That is, R equivalent is equals to R1 plus R2 plus R3. R1 is 2 ohms, R2 is 3 ohms, R4 is 5 ohms, right? So if you add all this, you will get 10 ohms. 10 ohms is the equivalent resistance when these 3 resistors are in series connection, right? Yes. Now we see question 2. Here, let's say this is the high potential difference, okay? And this is a negative terminal which shows a low potential. Let's say this is point A and this is point B. Now you can understand that the current is flowing from point A to point B, right? Yes. In this circuit also, you should see whether the current is dividing at any resistor or the same current is passing across all the resistors. So here you can see that the current across R1, R2, R3, R4 and R5, it is not dividing, right? So the current remains same at all the resistors. Let's say I. The same current is passing across all the resistors. Now we can say that all these resistances are in series connection. Let's say R1 is taken 1 ohm, R2 is 2 ohms, R3 is 3 ohms, R4 as 4 ohms, R5 5 ohms. Now as they are in series connection, what you will do to find the equivalent resistance? You will sum up all the resistances, right? That is R1 plus R2 plus R3 plus R4 plus R5, right? So 1 plus 2 plus 3 plus 4 plus 5. You see here 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. So that the equivalent resistance is 15 ohms. Done. Now we see question 3. Here you can see that, let's say, the current is passing from point A. Let's say this is point A. and this is point B. Now the current is passing from point A to point B. Okay. Now when the current is passing from the point A, here you can see that the current will get divided across each resistor, right? Let's say the current across R1 as I1, across R2 as I2, across I3, or that is R2 is I3, across fourth resistor I4. Now you can see that the current is dividing across each resistor. Okay, so that we can say that these four resistors are in parallel connection. They are in parallel combination, right? So to find the equivalent resistance of the resistors when they are connected in parallel connection, what is the formula that we use? 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Here we got four resistors. Let's say R1 is taken 2 ohms, R2 can also be taken 2 ohms. Let's say R3 is 2 ohms, R4 is 3 ohms. Okay. Now R1, let's say 1 by 2, 1 by 2 plus 1 by 2 plus 1 by 3. Now if you take the denominator for this, what you will get? 6, right? Numerator, what you will get? 3, 3, 3 plus 2. So finally, what you will get here? 3 plus 3, 6. 6 plus 3, 9. 9 plus 2, 11. That is 11 by 6. This is 1 by R equivalent. So if you take R equivalent, you should take the reciprocal of this value, right? That is 6 by 11. 6 by 11 ohms, right? Yes. Now, let's see the question 4 now. Here you can see that the current will start to move from high potential across all the resistors in the circuit and it reaches to negative terminal. Let's say the current will start from point A here, okay? And let's say this is point B, okay? The current will start flow from point A to point B. Now, if you see the current, let's say I is the current flowing through R1, the same current will passes through the R2. Here we won't see that current won't break down, right, across R1 and R2. But when it comes here you can see that at this point, the current will divide, right? So that as the current divides at this point, we can say that R3 and R4 resistors are in parallel connection. So first we will see what will be the equivalent resistance across R3 and R4. As they are in parallel, let's say I'm going to take R dash, 1 by R dash equivalent is equals to 1 by R3 plus 1 by R4. What is 1 by R3 here? R3 is 10, R4 is also 10. So as denominator is same, I'm just adding the numerators. 2 by 10. 2 ones are, sorry, it is 10, right? Okay. 2 ones are, 2 fives are. That is 1 by 5. This is 1 by R dash equivalent is equals to 1 by 5. But if you take R dash equivalent, nothing but the reciprocal of it, you will get 5 ohms. 5 ohms is the equivalent resistance. Okay. And then when it comes to the circuit now, so here these two resistors together, let's say I want to redraw this circuit. Okay, let's say this is R1, this is R2. Now together, R3 and R4 together, I just took a resistor like R dash, what we have point here, right? That is 5 ohms. Now, the current is flowing from point A to point B, right? Let's say this is point B. So if you redraw this circuit, you will get this circuit. Now, if you see the current passing through R1, the same current is passing through R2 and same current is passing through R dash, isn't it? So that the current is not dividing. I remains constant. So now you can say that R1, R2, R dash are in series connection. If they are in series connection, R equivalent can be taken R1 plus R2 plus R dash. Okay. What is R1 here? 10 ohms. What is R2? 10 ohms. R dash we got 5, right? Yes. So 10 plus 10, 20. 20 plus 5, 25. So R equivalent, the final equivalent resistance is 25 ohms. Done. Now we will see question 5. Let's say the current is flowing from, let's say this is point A. The current is flowing from point A to point B. Assume that this is the point B. The current is flowing from point A to point B. Let's say I is current flowing from point A to B. Now, at this point, you can see that the current is dividing at this point, and the current flowing through R1 is same through R2. So here you can say that across R1 and R2, the current is same. So we can say that R1 and R2 are in series connection. Let's say R1 is taken 2 ohms. Okay, R2 is also taken as 2 ohms. R4, let's take 2 ohms. R5 as 3 ohms. R3 as 3 ohms. Okay, let's take some values so that I have taken this. So now you can say that the current which is passing through R1 is not dividing. The same current is passing through the R2. Similarly, the current which is passing through R4, the same current is passing through R5, right? Yes. So that R1 and R2 are in series, R4 and R5 are in series connection. So let's take R dash equivalent is equals to, first I will take R1 and R2. Those two are in series, right? R1 plus R2. So what you will get? 2 plus, sorry, 2, 4 ohms. Now I will take these R4 and R5. Let's say R double dash equivalent is equals to R4 plus R5. These two are in series now. So the 2 plus 3, you will get 5 ohms. 5 ohms, right? If you redraw this, what you will get? Let's say, okay, if you redraw this circuit, this is R dash, this is R3, let's say this is R double dash. Now you can see that the current is dividing across these three. That is R1, R3, and R dash, R3, and R double dash. So here you can say that these three are in parallel connection now. So that finally, if you take 1 by R equivalent is equals to 1 by R dash plus 1 by R3 plus 1 by R double dash. Okay. So 1 by R dash. What is 1 by R dash here? 4. 1 by R3. R3 is 3. 1 by R double dash. 5. Right? So if you take this calculation. What you will get this as denominator. Now, if you solve it, what you will get? 4, 12, 60, right? You will get 60 as a denominator. Now, if you take this 60 with 1 by 4, so what you will get? 15, right? Plus 20 plus with 5, you will get 12. Okay. So finally, what is the value that you will get in the numerator? 35 plus 12, you will get 47 by 60. Okay. So this is 1 by R equivalent, 1 by R equivalent. So you want to take R equivalent, right? So that if you take the reciprocal of it, you will get 60 by 47 ohms. This is the equivalent resistance. Okay. Yes. And next, we see one more numerical. Question number 6. Okay, this is again a different concept. So here you can see that the current is flowing from point A to point B. Okay. Now you can see here the current is dividing at this point, okay, across 1 ohm. That is, let's say this is R1. Let's say this is R2. Let's say this is R3. Let's say this is R4. And this is R5. Okay. Now here you see that across R1 and R3, the current is dividing. Again at the point C, here you can see that the current will divide. The current will divide across R3 and R5, right? And you can also see the current which is passing through R3 will also get divides across R5 and R4. Here you can see that the two different amounts of current is passing through R5, isn't it? Let's say one amount of current is passing through the R5 and a different amount of current is passing through the R5 from this point. So that it's not possible practically. So there is a concept called a Wheatstone bridge concept. Okay. So as the different amount of current passing through a single resistor is not possible, right? So that as per this concept, that is Wheatstone bridge concept, we are going to ignore this resistor. That is, no current will pass through the resistor. No current will pass through this R5. So that you can ignore this. So finally, what you will get, here you can see that you are ignoring the R5. So that the current which is passing through R1, the same current passes through the, here it won't divides. You are ignoring this. So that the same current will passes through the R2. Now R1 and R2 are in series connection. Let's say R dash equivalent is equals to R1 plus R2. 1 ohm plus 1 ohm. You will get 2 ohms, right? Similarly, here also, the current which passes through R3, same current will passes through R4. Okay. So that these two are in series connection. R double dash equivalent is equals to R3 plus R4. Okay. So you can say 1 plus 1, 2 ohms again. Okay. Now, if you redraw this circuit, these together you can take as one resistor and these two as one resistor. Okay, let's say this is R dash, this is R double dash. Now you can see that the current which is passing from point A to B is dividing across R dash and R double dash. So that we can say that these two now are in parallel. So that 1 by R equivalent is equals to 1 by R dash plus 1 by R double dash. That is equals to 1 by 2 plus 1 by 2. What you will get? Denominator is same, so that I will add the numerators, that is 2 by 2, 2 by 2, 2 ones, right? You will get 1. If you take a reciprocal of 1, you will get the same, that is 1 ohm. 1 ohm is the equivalent resistance. Okay. Next we see question 7. Question 7. Here, if you observe this, this is the positive terminal and this is the negative terminal. This is high potential. Okay. The current is moving from high potential to low potential. So at this point, you can see that the current will divide across these two resistors, that is 14 ohm and 8 ohm. But the current which is passing through 14 ohm resistor, here you can see that same current will passes through the 10 ohms. That means 14 ohms and 10 ohms resistors are in series connection. So that I will take this as R dash equivalent is equals to 14 plus 10. What you will get? 24, right? 24 ohms is the equivalent resistance. And now, if you redraw this, okay, I will redraw this circuit with these equivalent resistors. Now, instead of 14 and 10 ohms, I can take 24 ohms, right? 24 ohms. This remains 8 ohms. Now you can see that the current which is passing will divide at this point across 8 ohms and 24 ohm resistors. So that we can say that these two resistors are now in parallel connection. 1 by R equivalent is equals to 1 by 8 plus 1 by 24. That is, if you take the denominator, it is 24. You can say 3 plus 1, right? You will get 4 by 24. 4 ones are 4 6. So what you will get? 1 by 6. But if you take the R equivalent, the reciprocal of it, 1 by 6, you will get 6 ohms. So R equivalent is 6 ohms. Okay. Now we will see one more numerical. Let's see the question 8 now. Okay, question 8. Let's say this is a positive terminal of a battery and this is a negative terminal of a battery. The current will start to flow from positive terminal, right? And then it reaches to the negative terminal. Now you can see that the current which is passing from R1 will divide across R2 and R5. Okay, R2 and R5. Let's say the current which is flowing through R2 and R5, the current is divided. That is, the current has breakdown here. And next, if you observe the current which is passing through R5, the same current is passing through the R4. So that now you can say that R5 and R4 are in series connection. Likewise, the current which is passing through R2, the same current is passing through the R3, right? Same current is passing. So that we can say R2 and R3 are also in series connection. So let's say, first you can take R dash equivalent is equals to R2 plus R3. That is 1 plus 2. That is 3 ohms. And next, R double dash equivalent is equals to R4 plus R5. What is R4 here? 3 plus 3. You will get 6 ohms. And then, now if you redraw this, okay, now you can see that I will take this as R dash and I will take this as R double dash. Now you can see that these two are in parallel connection now. The current which is passing through R dash and R double dash is different. It is dividing, right, across R dash and R double dash. So that R dash and R double dash are now in parallel connection. So that let's say RP, that is those who are in parallel connection. Okay. So if you take 1 by r dash plus 1 by r double dash, what is 1 by r dash? 3 r double, sorry, plus 1 by r double dash, that is 6. That is LCM, that is denominator, you will get 6, 2 and 1. What you will get? 3 by 6. If you further calculate it, you will get 1 by 2. That is 1 by R equivalent in parallel. Okay. So if you take the reciprocal of this, you will get 2 ohms. You will get 2 ohms. So again, if you redraw this, you will get the circuit like this, right? Let's say this is R1 and this is RP. Okay. You can see here the current which is passing through R1, the same current is passing through the RP. Now you can say that these two are now in series connection. So that R equivalent is equals to finally R1 plus RP. That is equivalent resistance of these R dash and R double dash when they are in parallel connection. R1 value is 1. So RP can be taken at 2. So finally what you will get? 3 ohms. So what is the equivalent resistance? 3 ohms. 3 ohms is the equivalent resistance. Now we will see the question 9. Okay, it's a ladder circuit. It seems to be like a ladder, right? So that I'm calling it as ladder. So if you take this battery, this is a positive terminal, so that the current is passing from point A to point B. Now let's say this is R1, this is R2, this is R3, okay? And this is R4, and this is R5, and this is R6. Now, if you observe the current passing through this at point P, here you can see that the current is dividing at this point. And again, at this point, the current is dividing, right? So the current which is passing through this R3, the same current is passing through R6. Here, there is no current dividing across R3 and R6. So that you can say that these two are in series connection. So that R dash equivalent is equals to R3 plus R6. That is 1 plus 2. That is 3 ohms. Now, these two I can take as this. Okay. I will redraw this circuit likewise. Okay, ignore this from here. So together, I'm just taking this as R dash. Now see here, the current which is passing through R dash and R5 is different. That is, the current is dividing at this point. Now R5 and R dash are in parallel connection. So that 1 by R double dash equivalent is equals to 1 by R5 plus 1 by R dash. What is R5 here? 2 plus what is R dash here? 3. So what you got? 6, 3, 2, that is 5 by 6. That is 1 by R double dash equivalent. So if you take the reciprocal, that is R double dash equivalent is equals to 6 by 5 ohms. 6 by 5 ohms. So again, here you can see that these together, you can redraw this circuit likewise. Okay. Now you ignore this from here. Now the current which is passing through R2, okay, the same current is passing through the R5. Now we can say that these two are in series connection. Okay. Let's say R triple dash, okay, equivalent is equals to R2 plus R5. What is R2? 1. What is here? R5 means here I can take R double dash equivalent, right? So this R double dash equivalent. So these two we solved and together we are drawing here. That is R double dash, right? Yes. Now, what is here? the R double dash in the place of R5. You just take R double dash. So R2 is 1, R double dash is 6 by 5. So you can write like 5 plus 6 by 5, right? What you will get? 11 by 5 ohms. 11 by 5 ohms, right? Yes. And now, if you take this circuit, I will redraw this. It is so clumsy, right? So now, finally, this R2 and R double dash together, I just took this as R triple dash. Okay, let's say this is R4, this is R1. Now, if you see that the current which is passing from R1 will divides here, right? Through R triple dash and R4. So that we can say that these two are now in parallel connection. Let's say RP, 1 by RP is equals to 1 by R4 plus 1 by R triple dash. Okay. What is 1 by R4? R4 value is 2 ohms plus 1 by R triple dash. What you got? 11 by 5, right? I will write 11 by 5. So further, if you take this likewise, 5 by 11, right? Denominator, what you will get? 22. It will be like 11 plus 10. So how much you will get? 21 by 22. 21 by 22. But if you take the reciprocal of that, you will get 22 by 21, right? Yes, finally, what happens here? If you redraw this, let's say this is RP now, okay? And this is R1. Now tell me, the current which is passing through R1 and RP are same. The current is same across these two resistors, so that those two are now in series connection. So finally, R equivalent is equals to R1 plus RP. What is R1 here? 1 ohm, right? So 1 plus 22 by 21. Okay. You can write 21 plus 22 by 21. Finally, what you will get? 43 by 21 ohms. 43 by 21 ohms. This is the equivalent resistance. Done. Now we see question 10. Here you see that the current is passing from point A to point B. Now, the current which is passing through R4 at point D, the current will divide, right? And the current which is passing R1, the same current will passes through the R2. So that R1 and R2 are in series connection now. We see that first. Let's say R dash equivalent is equals to R1 plus R2. What you will get? 3 plus 3, 6 ohms. Now, if you redraw this, okay, let's say this is R dash and this is R3, okay. This is R4 and this is R5, okay. Now you can see here at the point D, the current is dividing. So that you can say that these two, that is R dash and R3 are in parallel connection. So that 1 by R double dash equivalent is equals to 1 by R dash plus 1 by R3 is equals to, what is 1 by R dash? 6 plus R3. What is R3 here? 3. So what you will get? You will get 6, 1 plus 2. That is, you will get 3 by 2, right? 3 by 2. Sorry, 3 by 6 you will get. 3 ones are 3 twos are. So what you will get? 1 by 2. But if you take R double dash equivalent, that is the reciprocal of it, you will get 2 ohms. What you will get? 2 ohms. Okay. Now, if you redraw this again, okay. So here you see that this is R4, this is R3, this is R5. Now, the current which is flowing from point A to point B, here you can observe that the current which is passing through R4, the same current passes through R3. Here R3 means you can say that it is R double dash equivalent. Okay. So these two together, we have taken as one resistor. Okay, R double dash. And the same current passes through the R5, right? Same current will passes through the R5. So that we can say that R4, R double dash, and R5 are in series connection. So that we will take R equivalent is equals to R4 plus R double dash plus R5. What is R4 here? 0.5 plus what is R double dash 2 plus what is R5 here? Again 0.5. So finally, if you add all this, what you will get? 3 ohms. That is the equivalent resistance, right? That is the equivalent resistance of the given circuit. And next we see the question 11. Let's see what is this. Here you can see that the current, let's say the current is moving from point A to point B. Now the current which is passing through R, let's say here I'm taking this as an R1, that is 1 ohm. Let's say this is R2 as 1 ohm. Okay. And let's take this as an R3, that is 1 ohm. Let's take this as 4 ohms, that is R4 as 2 ohms. And R5 is also equals to 2 ohms. Okay. Now you see here at point C, the current which is coming from R1 will divide at this point, right? At C across R3 and R4. Now the current which is passing through R4, the same current will passes through the R5. So that now you can say that R4 and R5 are in series connection. So that R double dash equivalent is equals to R4 plus R5. What is R4? 2. R5, 2. So 4 ohms is the equivalent resistance, right? Now, if you redraw this, okay, here you see that, let's say this is R2, this is R3, this is R1, right? Now the current is moving from here and leaving here. Now this R4 and R5 together, I'm just drawing as one resistor. Okay, let's say this is R dash. Now you can see that the current is dividing at this point, right? So now you can say that R3 and R dash are in parallel connection. So that 1 by R double dash equivalent is equals to 1 by R3 plus 1 by R dash. Okay, I will take the value here 1 plus R dash 4. So what I will get? Okay, so 1 by R double dash equivalent is equals to 4 Here I will get 4 plus 1, that is 5 by 4 ohms. But we need R double dash equivalent, that is reciprocal. If you take reciprocal of that, you will get 4 by 5 ohms. Now, if you redraw this again, okay, this is R1, this is R2. Now, these two together, R3 and R dash together, I have taken this as one resistor, that is R double dash. Now you can see that the current which is passing through R1, same current is passing through R double dash and also through R2. So that now you can say that R1, R double dash and R2 are in series connection. That is R equivalent is equals to R1 plus R double dash plus R2. What is R1 here? 1 ohm. R double dash 4 by 5 plus R2 is 1. So you will get the denominator 5. You can take 5 plus 4 plus 5. What you will get? You will get 14 by 5. 14 by, sorry, here you will get 1, right? That is 1 into 4, you will get 4. Okay, fine. So 14 by 5 ohms. So what is the final equivalent resistance? 14 by 5 ohms. Done.